Let's start with the investment opportunity set and the minimum variance portfolios. Consider the universe of risky investable assets. It's important to consider investable assets here because there are some assets like the Taj Mahal which are not investable. We are only concerned with investable assets. And in this particular discussion, we are focused on risky assets, so there is no risk-free asset. These assets can be combined to create many portfolios. In fact, we could have millions of portfolios. This set of portfolios is called the investment opportunity set. You can think of these red dots as portfolios, and the combination of all these portfolios is our investment opportunity set. At any given level of return, there will be a portfolio with the lowest level of variance. The line combining those portfolios or connecting those portfolios is called the minimum variance frontier. And the name is fairly self-evident because it is giving us the minimum variance for each level of return. The global minimum variance portfolio is fairly self-evident. That's this portfolio here, which has the lowest standard deviation or the lowest variance. Next, you need to understand the efficient frontier, or more specifically, the efficient frontier of risky assets. The efficient frontier is the part of the minimum variance frontier that is above the global variance portfolio. You can think of the efficient frontier as all portfolios which give you the maximum return at each level of risk. The point is that at this level of risk, let's say this is 15%, you have a portfolio over here and a portfolio over here. Both these, say A and B, are on the minimum variance frontier. But clearly A is efficient and B is not, because an investor would prefer A. An investor would prefer the higher level of return at this level of risk. So this part of the minimum variance frontier is called the efficient frontier, and that is what an investor would be interested in. Now let's add a risk-free asset to our mix. The addition of a risk-free asset makes the investment opportunity set much richer than the investment opportunity set only of risky assets. With only risky assets, we had the minimum variance frontier and this part of the minimum variance frontier, which is the efficient frontier. Now we are saying that we also have a risk-free asset, and notice that this is outside the efficient frontier. So if we can invest in this risk-free asset, and we can also invest in all these portfolios which are on the efficient frontier, then there should be a way of combining the risk-free asset with one or more of these portfolios. We can create a capital allocation line which starts here at the risk-free asset and is tangential to the efficient frontier. It will pass through this point here called P, which is the optimal risky portfolio. This point is tangential to the efficient frontier. The way you can think of the capital allocation line is as follows. An investor at this point is 100% invested in the risk-free asset. At this point, an investor is 100% invested in this optimal portfolio. You can think of this optimal portfolio as a bundle of risky assets, and then think of that bundle as one single bundle. Now the investor is either using this bundle called P or the risk-free asset, or some combination of the two. Points on this capital allocation line represent different weightages between the risk-free asset and this portfolio P. Here the investor has 100% in the risk-free asset. Here he has 100% in P. At this point in the middle, he would be 50% in the risk-free asset, 50% in P. Here he would be 75% in P and 25% in the risk-free asset, and so on. So like before, this is simply a difference. As we move along this line, we simply have a difference in weightages. In the example that we saw earlier, we just had two assets, the risk-free asset and another asset. Here, this P represents a bundle of assets, but conceptually what we have talked about here is extremely similar to what we talked about earlier. Another point is that this line, the CAL, is based on the market, not the investor. On the next slide, we will introduce indifference curves related to the investor. To identify the optimal investor portfolio, we must also consider the utility of the investor, which is represented by his indifference curves. First, let's go back to the CAL, which we created on the previous slide. The CAL is based on the market, not the investor. It represents the most efficient portfolios for each level of risk. And if you think about it, the CAL is even more efficient than the efficient frontier, because with the efficient frontier we had a constraint. The constraint was that we can only use risky assets. With the capital allocation line, that constraint is removed because we can combine the risk-free asset with risky assets. I am skipping the efficient frontier here and simply showing the capital allocation line, which we hopefully agree is the most efficient set of portfolios at each level of risk. The question now is, what is the optimal portfolio for the investor? For that, we need to understand the risk aversion level, or the A, for the investor, and we need to draw his indifference curves. And we have done this before. We will create these indifference curves, and at the point where the investor's indifference curve is tangential to the capital allocation line, represents the optimal portfolio for the investor. This is a lot like what we've seen earlier, but here the difference is that we are using many assets. Earlier we just used a two-asset portfolio. So that's the optimal point. That is the point where we have the highest indifference curve, which makes the investor as happy as possible. That curve is touching the capital allocation line. So this is the optimal investor portfolio. You can think of these indifference curves also, which would make the investor even happier, but these indifference curves do not touch the capital allocation line. So this would make the investor happier, but there is no option available. The market does not offer portfolios that give you this level of return at a particular level of risk. In other words, the capital allocation line tells us what's possible given the market. The indifference lines tell us what makes the investor happier. We need to connect the two to come up with something that is practical and makes the investor as happy as possible. And that again is this point over here. We are done with this very long reading. Let's quickly cover the summary. We talked about the return measures and their applicability. So you need to understand the concept of holding period return, arithmetic mean, which is used when you have returns of stocks in the same time period, geometric return, which makes sense when you are looking at time series data. We have money weighted return, which is essentially the IRR. It makes sense to use this return when the investment manager has the ability to decide when to get in cash and when not to get cash. We talked about the characteristics of major asset classes. This means the return characteristics, the risk characteristics, covariance, and so on. We also talked about skewness and kurtosis, risk of a portfolio, The portfolio standard deviation is a measure of the risk, and you must know the formula for coming up with the portfolio standard deviation. Correlation and portfolio risk, you need to recognize that as the correlation between assets decreases, the portfolio risk goes down. Minimum variance frontier, efficient frontier, global minimum variance, these are important points. So this is your minimum variance frontier, which gives you the lowest variance for a given level of return. This is your global minimum variance. The points above this represent the efficient frontier. We then talked about the capital allocation line, which connects the risk-free asset with the efficient frontier. This is the optimal risky portfolio. And then to come up with the optimal portfolio for an investor, we need the indifference curves, and we have to find the indifference curve which is tangential to the cal. That's it for this reading. I want you to do the summary, review the learning objectives. I have asked you to do the examples. They are good. Do the practice problems. For a change, we have quite a few over here, so make sure you spend time on them. But nevertheless, try to do questions from other sources as well if you have time.